Hi everyone and welcome to another lecture. In our past lectures we learned about vector spaces, and today in this short lecture we will talk about something called a subspace of a vector space. So what is a subspace? Again we want to start with the definition. Okay, let me change that. Right. So what does this definition say? Let's say we have a vector space. Let's say we have a vector space. So let's say we have a vector space called V. Let's put some apostrophes so that we can distinguish. And from this vector space V, that is this capital V, a subspace is something we denote by W. That is, we are calling W a subspace of V if we take two elements, let's say small v and small w, and they belong to this capital W. I'm putting the apostrophes just to make you understand the difference between this small w and the capital W. And for this, so let's say this is true, this v, small v and small w belongs to W, capital W, then the small v plus small w also belongs to capital W. And similarly, if v is an element of W, and let's say I have some number called c, this is a number, so it belongs to some field K, then this c v also belongs to W. That is, this CV is also an element of W. And the element, that is, we learned 2 lectures ago that the zero vector, let's call it right now this with a bold, okay, that's not nice to look at, so let's call this thing a zero vector. We're calling it as the zero vector, and this is also an element of W. So if W satisfies these things, then this is called a subspace. And you can notice that by telling these properties or saying these properties, we are implying that W itself is a vector space. And there is a thing to notice is that this V and W will this V and W, that is the small v and small w, so let me use another color to highlight them. So this one and this one. So this small v and W, both of them belongs to capital W, right? And the crucial fact about W is that W is a subset of V. So we should have said this earlier, but the reason I'm telling you now, because at first we wanted to see if I take elements in W such that they form a vector space, and then I'm telling you that this W is actually a subset of V. So that's why the name subspace came in, because V was a vector space, right? And from there, that is from the set of V, you are taking some elements, and now you want to see whether the conditions for the vector spaces are satisfied or not. And if you can satisfy them, then the resulting space is called a vector subspace of the subset of the vector space V. That is, you have something bigger, then you are taking you have a bigger space, you are taking some elements of it, and by doing that, if you are also getting a vector space structure in that smaller region or the smaller space, then you are calling that thing as a subspace. So what can be an example of subspace? So let's try to take a matrix. Let's say, okay, this is not a good color, so let's just go with black. Let's take a 3 cross 3 matrix A, and I have some real numbers over here. Now this is a 3 cross 3 matrix, right? And now if I take the part that is, let's say I want to have this part cut out, and I want to write it as some other matrix. Let's call it C, and I'm writing it as 1, 2, 6, 7. This kind of matrix, that is the C, it will form a vector space of its own, and this A, it forms a vector space of its own. So you can say that all these blocks you can make out of here will form a subspace from this 3 cross 3 matrices. That is, assuming in this case we are that these 3 cross 3 matrices form a vector space, and the subspaces can be constructed by taking 2 cross 2 matrices and even 1 cross 1 matrices, because 1 cross 1 matrix is just a number. Remember from our lectures on matrices. So I can even take these things over here, and they will form subspaces as well. So this will be it for today. I hope you enjoyed it, and I'll see you guys on the next lecture. Thank you.